Okay, this is the second part of this regression assignment where they focus a little bit on, well, there's three questions here and they focus on the correlation coefficient and what it tells us. Okay, so the first thing, there's a pH level of dams and they're different distances away from an industrial complex. And they want to see if this industry, is there a correlation between how far you are from the plant and what the pH of the water is. Okay, so it's just the same thing where you go to a mode stat, but it's a regression because you have two sets of variables here. The first one is you're going to put in is how far you are away and see if it affects the pH level. So the top one is X's and the bottom one is Y's. You just hit a mode stat and then hit the A plus BX because you're going to get all the information. You could get the equation of the line that goes through this scatter plot, a line of least regression, or you can get something called the correlation coefficient. They ask, calculate the correlation coefficient and comment on the strength. Well, I just put everything in, put in all the data, then I pressed AC, I cleared it, then I went shift stat and I hit regression, REG, and then I hit, I think, well, the number that's got a little R there, and out came 0.504. Well, if this was like 0.0.1, there'd be almost no um, positive correlation. It's a positive correlation, but it's just weak. It's a weak positive correlation between the pH level and the distance. If it was zero point 0.8, it would be reasonably strong, but not very strong. There would be a positive correlation, but not. And if it gets around zero point 0.9 or anything over that, it's very strong. And that's what we do with the number of cigarettes put in here and the number of cancer cases. I put this data into my calculator, and then I pressed AC. I'm looking to see if cigarettes are correlate with lung cancer. So these go in for X, these go in for Y. Press AC, shift stat, regression, and then look for the little R there. And there it is, 0.947. Hey, that's really close to 1. 1 isn't 100% correlation, but this is a strong positive correlation between the number of cigarettes smoked and the number of cases of lung cancer. Well, by the way, correlation doesn't mean one thing causes the other because there could be some other factor involved, but that's another story. But there's definitely a strong positive correlation. Okay, let's look at the next question. Well, there's lots of things. We put all this data in here. The number of the dates in the month of July, 4, 6, 10, 12, during the Haoteng winter month of July, it's the number of patients that visited a local hospital suffering from flu. The table below shows the number of patients treated. So these are your X values, you put them in. These are your Y values, you put them in. Press AC, and to get the equation of least squares regression, you go shift stat, then hit the REG thing, and you'll see A as a possibility, you'll get that number, and B as a possibility, you'll get the equation of this. To graph it, you'd have to put the days in the July, from the 1st all the way up to the 31st, put the days in July, and then the number of patients treated somewhere, in the level of, I would just start with a 0 and go all the way up to 900, make a scale like that. Now, I cheated a little bit. I'll show you on the other page right now. I got a computer to do this. Now, the computer gave me this equation. They've got A here and B, the gradient. It just gave me the equation of the regression line, and it graphed these points. I don't know why it pushes the x-axis up a little bit too high here, because it should be down below, but there's the 4th of July, the 6th, the 8th, the 10th, like that. And there's your 400, 600 patients, 800 patients. So that's how it goes. Now, say you were asked to sketch this line, to put this line of least regression on the graph. Well, you'd go to 0 and oh, let's just do the calculator. I did this in my calculator, and oh, I did this on my calculator, and I got A was 118.6, just like they got, same thing, but 118.6, that's the y-intercept. So I'd go to 0 and 118.6, that's my y-intercept. I just picked a number. I'm going to get the equation here too. I found the b value, and there's my equation right here. Y equals, oh, that's r. I don't want r yet. Here's the equation down here. Okay, yeah, there's the y-intercept. When x is 0, y is 118.6. There's the graph. If I put 24 into this equation and I work it out on my calculator, I get something very close to 800. Now that's the one I would graph, 24 and up to 799.48. Connect those 2 points, and that's your line of best fit. Um, some people like to find the mean of both things. So what they do, so there's the line. I put 24 in there. I put it into my calculator, and I got very close to 800. But you can also go back and look at the data and press variance when you go shift stat and get the mean. So you can graph 14 and a half and 530, and that will fit right in the middle of the line. The mean of the x values and the mean of the y values. Okay, that's one thing. Now, the next thing, they ask for the correlation coefficient, I think. Oh, maybe they don't do that to the end, but I'll just answer that question. It's 0.988. That means it's very strong. There's a strong correlation between these two things, between the month of the day and the patients treated. Okay? There's a strong positive correlation between them. But then they ask you to predict how many patients are going to be on different days. Well, you just use your equation. On the 23rd of July, put in 23 into the formula, and you get 771 patients. That's what you predict. That's on the line here. And if you want to, on the July 31st, that's going a little bit outside because it ended with a piece of data that wasn't as far as that. But if you put 31 in, you get 998 patients. That would be the prediction there. They said June 28th. That's 2 days before July starts. So I put in -2. I think that kind of makes sense. You put it in, you predict 60 patients on June 28th in the winter. I guess you just get more and more and more as the flu season goes on. That was this strong correlation that happened. Okay, that's all the questions in our special assignment, and all explained. Okay.